The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. All right, so today we're going to review for the Chapter 9 test. So do you have any questions from the homework assignments from yesterday?
Yes, can we look at number 30 on the review?
Okay, let's see. Sarah, review. Number 30?
Yes, the second to the last.
It would help if I was on the right section. I was looking at chapter 8. I've just been working on fall quarter and I finished up with chapter 8. No excuses, just get on with it. No one else cares. Okay, sorry. Let's take a look here. All right, now, so you said which one? Number 30.
Number 30, yes.
Yeah, okay, I see it there. Just a minute, we'll bring it up. Okay. All right, solve the equation. Okay, so we have the square root of 2x plus 9 equals 7. Okay, so we're going to take that and to solve it, we would start by isolating the radical term. So we have the square root of 2x equals -2. The next thing we're going to do is square both sides. So we get 2x equals +4. -2 times -2 is +4. Divide both sides by 2 and we get x equals 2. So that is the proposed solution. Okay, let's check it. Square root of 2 times 2 plus 9 equals 7. Square root of 4 plus 9 equals 7. 2 plus 9 equals 7. 11 equals 7. Not true. Okay, so now let's go back to the WebAssign screen. Solve the equation, write all proposed solutions. Okay, so instead of 20, it should be 2. If the solution is extraneous, so indicate, meaning that it does not work. So you're right, it doesn't work, but the solution you should have come up with was 2 instead of 20. You all right with that?
I see, yeah, I see what I did wrong.
Okay. Any other questions, anybody?
I had a question on 9.5.
Hang on, just a second. Okay. And let's get back. All right, who's asking, Elena?
Yes, number 12.
Hang on, let me find, let's see. 9.5. 9.5, number 12. Okay. All right, let's take a look at that one. So it says, solve the equation, enter your answers as a comma-separated list. Okay, so we've got the square root of 8 minus 2x equals 6 times the square root of x minus 4. Okay, so taking a look at the whiteboard screen, we have an equation with 2 radicals, but only 2 radicals, and they are already separated, so that's good. So now we want to square both sides of the equation. On the left side of the equation, we're going to get 8 minus 2x. On the right side of the equation, however, we're going to get 6 squared, and then the square root of x minus 4 squared, which is 36 times the quantity x minus 4, which is 36x minus, what is that, 144? Okay, you follow how I got from here down to here?
Yes, I see where I went wrong.
Did you forget to square the 6?
I squared the 6, but I didn't branch out like the 36. I didn't multiply that by -4.
Gotcha, gotcha. Okay, well, let's finish this. So next, let's see, we'll subtract 36x from both sides, which will give us what? -38x plus 8 equals -144. We'll subtract 8 from both sides. -38x equals -152. We'll divide both sides by -38. X equals, let's see, negative divided by negative is positive. So we've got 152 over 38. Does 19 go into 152? Let's see, 150, oops, turn it on. 152 divided by 19. Aha. So I'm going to divide the top by 19 and the bottom by 19, which is going to give me 8 over 2, or just 4. So x equals 4. Let's plug that in to check it. We'll do that right in this little box area here. So I've got the square root of 8 minus 2 times 4 equals 6 times the square root of 4 minus 4. So we got the square root of 8 minus 8, which is the square root of 0, which is 0. Over here, we've got 6 times the square root of 0, 6 times 0, 0 equals 0, so it checks. All righty?
All right, got it. Thank you.
Okay. Any other questions, anybody?
Yeah, can you do number 19 on the review?
Okay, and who was that? Jamie?
Yeah.
Jamie, number 19 on the review. Okay, let's see here. Other class. I always have to figure out which of the two classes you folks are in. There we go. You said 19 on the review?
Yeah.
Okay. Okay. You are so close to the right answer. All right. So you have 1 over 1/32, okay?
Mm-hmm.
Which is 1 divided by 1/32, right?
Mm-hmm.
Which is 1 times the reciprocal, which would be 32 over 1, which is 32, and that's the right answer. So what you did before was fine, you just didn't simplify it far enough, okay?
Okay.
Does anybody want me to take the problem from the very beginning? We're good? Okay. All right. Other questions from homework? Anybody? Okay. Well, let's go through and let's highlight some things just to remind you of some things. So let's take a look at, let's see here. Get rid of this. And let's see, at section 9.1. We have the idea that if you take the nth root of x to the n, you get x. If what? X is greater than or equal to 0. In other words, the cube root of 17 cubed is 17. The fourth root of 81 to the 4th power is 81, etc., etc. Let's talk about the absolute value stuff, because I know that gives people trouble. So what you've got to do, you've got to read the directions very carefully. if it says assume all variables are positive, then you don't need to worry about absolute value in that problem. But if it says all variables are unrestricted or all variables can be any real number, then you've got to be careful. Recall, when you take an even root of a number, you can't get a negative answer. So that's when you've got to be careful. So let's say I'm taking the fourth root of x to the fourth power, and I'm told that x is unrestricted. X could be any real number. Well, I get x, but I'm taking an even root, and x could be negative. So in this context, I have to put absolute value bars around it so that if x is negative, the final answer is still going to be positive. Okay. Let's say you've got something like the square root of 36t squared. Again, the directions say t is unrestricted, or t can be any real number. So you get 6t. However, because you're taking an even root, you would need to put absolute value bars around the t so that if t is negative, you still get 6 times a positive number, giving you a final answer that is positive. Okay.
I have a question.
Yes.
On the review on number 2 and 3, why does it have you use absolute values on number 2 and not number 3?
Okay, so let me get back into WebAssign. Hang on. All right. Let's see here. Yeah. Okay, so we're looking at the chapter 9 review. And your questions again were, why does 2 use absolute value bars and 3 does not?
Yeah.
Okay. All right, that's a good question. Let's take a look. Problem number 2. It says, simplify the expression, assume that the variable is unrestricted, and use absolute value symbols when necessary. All right, so we get 5x. We're taking an even root, so the answer has to be positive, okay? Since x is unrestricted, x could be negative. So in this case, we have to do that. Now, I noticed that you did this, which yields the same result, which is why it said it was fine, okay? But let's take a look at number 3. Same direction, simplify the expression, assume that the variable is unrestricted, and use absolute value symbols when necessary. So this becomes 7h squared. Now, why don't we need absolute value bars around the h squared? Because it's squared, even if h is negative, a negative squared, so a negative times a negative, would still yield a positive. So we don't need them here because h squared can't be negative because it's squared. Is that making sense?
And then why can it on this number, on number 2 then?
Because here, when you've got just, let's say you just leave it as 5x, x could be a negative number, and 5 times a negative times some negative number would be some negative.
Oh, okay. So the
Right?
answer is squared,
Okay.
not the question. Okay.
Yeah.
Gotcha.
All righty. What else? Well, let's see. If you come up with other questions, I'll leave WebAssign open. Let's see here. So graphing a function, domain and range. Maybe I should ask you, do you have any questions that you'd like to look at? General concepts from section 9.1. That's where we dealt with taking basic roots, absolute value. We did some graphing, domain and range. Anything there? Finding function values. Okay, keep in mind, again, okay, so you can't take an even root of a negative number. So like the fourth root of negative 16 would be not real, okay? When you take an even root of a number, that answer can't be negative. So if x is unrestricted, you'd have to make it positive by using absolute value bars. Now, what if you're taking the cube root of x cubed? When the root or the index is odd, you can have a negative answer. So when it's even index, you can't have a radicand, the stuff inside can't be negative and the answer can't be negative. But if it's an odd index, you're okay either way. How about converting back and forth between rational exponents and radical form? This was section 9.2. Any issues there? For instance, if you've got, let's say, x, let's see, the cube root of x squared, that would be x to the 2/3 power. The index is the denominator of the exponent. If you had, let's say, the fourth root of x to the 3rd power, that would be x to the 3/4 power. Let's say you're trying to evaluate y, or say 7 to the 2/3 power. So on your calculator, you would put in a 7, and then if you have the little caret key, you would use that. If you have the x to the y key or the y to the x key, all three of these accomplish the same thing. You put in the base, which would be the 7, then you push whatever that power key is that you have on your calculator. And then since our exponent is a fraction, we would put parentheses 2 divided by 3, close it up, equals. Okay. Do you have any questions, anything about that you want me to go over again or in more detail? All right. Recall that a number to the 0 power equals 1. So let's say I had x to the 2/3 times x to the negative 2/3. That would be x to the 0, which is 1. Let's see here. How about simplifying and combining radical expressions? 9.3. I know I'm going kind of quickly, but unless you have some specific things you want to look at, I'll assume that you're good to go. Recall that if you have a fraction under a radical, you can separate it like that. If you have a fraction of two radicals, you can combine them like that, assuming they have the same index, okay? Also, on your answers, if you have an answer to a problem, let's say it's the cube root of something, make sure that if it's anything other than a square root, that you put the index in. Back in the day when we were in the classroom so long ago, quite often I'd have a test like this and people would get 100%, except there'd be a problem where they wouldn't put the index of a 3 or a 4 or something in, and they'd miss that problem. So little details, be careful. Okay. Simplifying a radical. You're going to take everything that you can from the inside and kick it outside. So if I've got the square root of 75, I guess that has a longer tail than it needs to have. There we go. 75 is a square times 3. So I could write it this way, but then the square root of 25 is a 5 outside, and the square root of 3 stays inside. Make sure you take the right number outside. I've had people take this and write 3 square roots of 5. So careful what you're doing. The number you're taking the square root of, the result of that goes outside of the radical. Okay. Let's see here. What if you've got something like this, the cube root of 80. All right, so 80 is 8 times 10, which is what? This is 8 and this is 10. So you've got 2 to the 4th power times 5. Since we're dealing with a cube root, okay, we'd break it apart like this, 2 to the 3rd times 2 to the 1st power. Then we've got what the cube root of 2 cubed is 2 outside. And then inside I've got 2 times 5. And so then we take what's left inside and multiply it together like that. Okay. What if we've got something like this? How about the cube root of, let's say, 16x to the 7th, y to the 14th. All right. So 16 is 2 to the 4th, or 2 to the 3rd times 2 to the 1 power, okay? X to the 7th, I'm going to break that down as x to the 6th, because 6 is the highest multiple of 3. It goes into 7, and then I still got x to the 1 power left over. Let's see. 3 goes into 14, what, 4 times, so 12, so y to the 12th, and then y squared left over. Again, do you see what I'm doing there, folks? I'm matching the index or multiples of the index for my exponents. So there, there, and there. Now, the cube root of 2 cubed is 2 outside. This 2 is stuck inside. The cube root of x to the 6th is x squared. This is stuck inside. The cube root of y to the 12th is y to the 4th, and this is stuck inside. So my final answer is pretty much that. I'll just write it here in black. 2x squared y to the 4th, cube roots of 2xy squared. Okay? So the key is to focus on the index, match the index, or multiples of the index. The leftovers are going to still be inside. 9.5, solving radical equations. If you have an equation with one radical, isolate that radical term before doing something to both sides of the equation. If it's a square root, square both sides of the equation. If it's a cube root, cube both sides of the equation. A big mistake that students will make is they'll have something like this, and they go in and do this. Okay, that's not a good thing. It's going to give you a mess. Even if you do it correctly, it's going to give you a mess. So you want to isolate the radical and then square it or cube it, whatever it takes. Okay. When you do this process, always, 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 always check your answers to see if they are extraneous, meaning that they don't work. Okay. Well, that's all I've got. Is there anything else you want to look at before we go? Okay. Well, then I'll go ahead and stop the recording. I'm kind of going slow here in case anybody's changing their mind. Okay.